All right, hello everybody and welcome. My name is Christina Lee and I am a software engineer at Pinterest. Today we're going to be talking about SBA, which is an acronym that stands for the State-Based Architecture. To set the scene, we have to go back to December of 2021. Our platform lead, Shasha, had called a meeting of all of our platform engineers and some of the most senior people in our product org. She'd done so because it was clear that there was a problem. The industry was changing very, very fast, and things were coming at us one after another. Things like GraphQL, Compose, coroutines, any number of very large changes. Now, up until this point, we had been reacting, and we had been handling them. We had been integrating them, we had been shipping them. Things were generally going okay. But as Grug might say, the complexity spirit demon was upon us. We had a 10-year-old code base, and every time we reacted to one of these major new technologies that our code base was not originally designed for, the strain got a little bit more and more aggressive. Now, confoundingly, nothing had actually gone wrong to get us to this point. What we were struggling with was not unusual or unreasonable, and in fact, it's not something that you can entirely eradicate from any code base. Complexity and tech debt, those are things that exist for everyone. And a lot of our stakeholders were actually quite happy with where we were. Our developers were pretty happy, and our code base was decently modern given its size and how old it was. So this meant that while it felt like we were in a critical moment in this meeting, and it really felt like action needed to be taken, it was not exactly clear what that action should be, because we did not have a clear thing to unite against. It would be very easy if we said, right now we have tech debt, and our goal is to have no tech debt. But you can't say that because that's not a realistic goal to achieve. So instead, in that meeting, we had to decide what we could achieve and how we wanted to do it. And that is the story that I'm going to tell you today. Now, I hope that your takeaway from this is food for thought. What I will say is that I do not think that the decisions that we made are going to be right for you. In fact, they might not even be right for us. Time will tell. But what I do think with my whole heart is that watching other people navigate different problems can help you navigate them better yourself. And so with that, I'm going to lead you through this story in 3 different steps. First, I'm going to tell you what led up to that meeting when we realized that something needed to be done. Second, I'm going to tell you what we actually did and how we responded. And third, I'm going to leave time to evaluate our performance and give you the honest pros and cons and the open questions that we still have about the way we decided to react. Now, fair warning to anybody who's here expecting this to be a deep dive into the implementation of the architecture, it will not be that. That would be about a 5-hour presentation in and of itself. I will go over some of the details, but this is largely going to be about the process at a higher level. So let's start with part 1. 7 years ago, right after I had joined actually, Pinterest adopted MVP as our very first architecture. Before that, we had no official architecture, and everything was intermingled as you might expect. Now, I want to tell you the background against which we decided to adopt MVP. We had about this many developers, and it turns out when you have about that many developers, everybody still knows everybody. This is the phase in a company where when people go out for Saturday and Sunday weekends, they come back on Monday and you know that they had an ultimate frisbee game, or they were attending their dog's birthday party or flying off to a friend's wedding, and you get to ask them about that stuff. And that knowledge that you have of them as a person translates to their code. You often know what everybody in your team is working on and why they're working on it and how they're planning to accomplish it. Now, this was also a time before we had all collectively lived through a global pandemic. Yay, those days. And what that meant for Pinterest was that we were all still working out of one office in person. And what that means if you're a developer is that when you need help, you do that famous spin move in your office chair and you say, hey, you got a sec? And people usually did have a second. And so what that meant is that if you were struggling with code, you almost immediately had access to the help you needed to navigate it, and there was a lot of cross-pollination of ideas. Now, this was also a time before Pinterest had gone public. And the downside of that was that we were getting paid in fake money, which wasn't always fun. But the upside was that we still thought that socks were things that you wore on your feet. It was a lovely era, that was. Now, also, this was during the period when Google was still very much leaving libraries up to the community because they trusted us to know what was best, which I just want to say that was so very sweet of them. Like, honestly, it's very, very nice. And so this was the backdrop against which we decided to adopt MVP. Now, there were two parts of that decision that I really, really loved and that worked out well for us. One, MVP was very flexible. Very, very, very flexible in the way we implemented it. And the benefit of that flexibility was that we could move fast. It turns out that when your implementation has very few rules, you can do things very quickly. And for a small company, that's lovely. We were still trying to get our foot in the marketplace. We were still in that scrappy startup mindset. And so being able to move fast, it is hard to overstate just how important that is. Now, secondly, MVP was not a particularly gatekeepy architecture. There's not a lot of custom words that you need to understand the definitions to, and the rules of following it are pretty simple. Don't put logic in the view layer. That gets you most of the way there. So as a small org who didn't have a dedicated team for onboarding purposes, MVP made a lot of sense. Now, unfortunately, even though it had some perks, the cracks began to show almost immediately. First and foremost, we had adopted MVP by telling our stakeholders that we would increase our test coverage. Going from no architecture to one where everything was separated should get us test coverage automatically, right? Wrong. It turns out that our implementation of MVP was actually still quite difficult to test. The setup of our presenters made it hard to just get the test to compile. And then even when we had tests there, they weren't testing things that were giving us huge ROI. On top of that failure to deliver our primary objective of increasing test coverage, we were also seeing flexibility backfire in some important ways. One, our features were very inconsistent because everybody could write their own flavor of MVP. Two, this also meant that we were having logic leak into the views because that was the system that everybody had been writing before we went to MVP. And because there was a lot of flexibility and no rules to keep people from continuing along that inertia path, they just kept doing it in MVP too. Now, this was not according to the rules of MVP, but it happened nonetheless. And if you looked at views in our code base, you would see a significant amount of logic continue to build up in them. Also, in MVP, we did not make a plan from the get-go to break up large features and to understand how we should introduce sub-presenters or whatever concept we wanted to have to break up code into reusable bits within the same feature. And so as a result, as we ported our most complex features into MVP, we ended up with these huge bloated presenters that, yes, they were out of the view layer, but they were still tremendously complex. And of course, this was just what we got wrong from the start. Now, I'm saying that in jest, of course, because hindsight is 20/20, and it's so easy to pick yourself apart when you have the benefit of knowing how everything played out. But I do want to say that it was clear, in hindsight, that we were starting from a somewhat rocky foundation. And from there, things only escalated. Because where we started with this many engineers, we grew to about this many, and all of them wanted to ship features, and all of those features were getting more complex over time. So regardless of how you cut the complexity metric in our code base, if you did it based on the number of developers we had, if you did it based on the number of features or the complexity of features, or even if you did it on business guidelines around like the requirements of our features on performance or logging aspects, or the number of times we were reorging or the scale of our developers and how many people we were onboarding, that graph always looked the same, which is that it was moving up and to the right. And so as we had that rocky foundation, we added more pressure to it, predictable problems came up. First and foremost, more bugs. The most costly part of our development experience is tracking down all of those bugs and reacting to them. Second, because we'd failed to deliver easy unit testing, we were relying on a much more expensive form of testing, both financially and organizationally, which was integration tests. Third, because nothing was implemented in the same way, adopting new features or new technologies was pretty hard because you couldn't just say, we're going to put GraphQL into our code base and all the features will adopt it in this way. You had to say feature A will adopt it in this way and feature B will adopt it in this way because they're not written the same way. Now, as a result of these factors, A/B testing became a crutch. It is a very valuable tool. It works very well, but it is also very slow because when you put something behind an experiment gate, you need to wait for your branch to ship, and then you need to wait until you have stat-sig data to prove that it's safe. And that is a long process. So while it works, what you start to see is velocity decreases because you're using it in that way. And of course, eventually you end up with less happy developers because nobody wants to feel like they're slow at their job. So while it originally was written like this, I would prefer to update this childhood ditty by saying first came growth, then came pain, then came the state-based architecture. Thank you, I was so proud of that, I'm not gonna lie. All right, part 2. Let's talk about what we actually did. In order to do that, I should probably at this point actually tell you what SBA is. Now, I firmly believe that there's really not much new under the sun when it comes to architectures, even though we all have our custom names for them. MVP, MVVM, MVI, they're all flavors of the same opinions that you should organize your code in some way. So, true to that, SBA is a form of MBI. Specifically, it's a form of MBI with pizzazz. And now, I've said that things are very similar, but I really don't want to downplay how important that pizzazz actually is, because nobody integrates a theoretical architecture into their code base. We all could describe what these architectures do, but at the end of the day, each of us needs a concrete implementation of one. And the concrete implementation is what can make or break the architecture in your code base. MVP could have been successful or more successful in our code base if we had implemented it differently, but we didn't. It was the implementation details that really hinged on our success and failure. And so with that, I want to take this time to look at the specific details that make our particular flavor of MBI. First and foremost, we took aim at flexibility. Now, it's so painful to have this slide because flexibility has a very high net promoter score. Almost everybody loves flexibility, and if someone says that they're taking it away, that's usually a bad thing. But while flexibility was so important to our growing org, it became the basis of the vast majority of our problems once the org was bigger. So take aim at it, we had to. Now, the ways we did this, some of them were pretty standard. We recommitted to that boundary between the view and the logic layer. Specifically, we set up very strict communication patterns between the two and strict responsibilities. The view could take in a description of itself that it would render, and it could send events to something that knew how to process them. That's it. That's the only thing it can do within our architecture. The logic layer was the complement to that, which is that it could receive those events and generate new descriptions. Now, when you translate this to code, it looks something like this, where what we call our view descriptions is display states, and we have an event intake, which is that pipe that allows events to flow through our system. Now, if you've attended DroidCon in the past, this actually won't look at all new. You've seen it on stage before. This is the same paradigm that many companies have. But as I mentioned, the devil is in the details. So let's take a moment to look at one of those details. Our event intake, as you can see highlighted on screen, is parameterized by something we call a feature event. Now, a feature event, as you might guess, is implemented as a sealed interface. And the benefits of doing that is that you get your exhaustive when statement when you're handling the events. Nothing revolutionary there. However, this beautiful, wonderful, clean system immediately falls apart, especially on reusable components and events that you want to occur in many features. So naively, let's say that we have an event that we want to be in 2 separate features. Here we're calling it onActivate. We can do it like this. We can just re-implement it for every feature. Now there are some obvious costs to that, like the fact that you have to put it into every feature when you're starting, and the namespace issues around having 500 onActivate events in your code base. But the subtler cost of this is that none of these onActivates are now tied at a compilation level. They all represent the same lifecycle idea, but there is no implementation that ties them together, which, if you want to provide tooling, is problematic. Now, you might immediately think, that's fine, this is a solved problem. Let's just create a new sealed interface called lifecycle events. We put onActivate there, and our feature implements that interface and gets this. That would be great, except for if you have a modularized code base, because when you have sealed interfaces, they must be declared in the same package. Womp, womp. So what did we do? Option 3, we added wrappers. Now, I went through this example specifically so that you could see how very, very uninspiring this code looks. Nobody is going to have tears of joy when they look at this wrapper and they think about the need to wrap and unwrap constantly across our code base. They might have tears, they're just not going to be of joy. And I wanted to show you this because the vast majority of our decisions followed this pattern, which is to say that in a vacuum, if you have developers used to going from point A to point B very quickly and unencumbered, and you add misdirection in there and they have to take a longer route, it feels awful. It feels like peak corporate bureaucracy. They used to be able to do it fast, and now we've given them a detour. However, we're not operating in a vacuum, and we're not optimizing for the single developer case anymore. We're optimizing for a picture that looks a heck of a lot more like this, where we have many developers with many goals, and oftentimes those goals are not in alignment. Take, for example, our performance team that wants us to have faster app performance, and our feature teams, which insist on keeping and adding more code into our code base, which slows it down. Those teams both have their goals. Those goals are at a crossroad, and both of them are important. Now, anybody who has tried to move in a group of many, many people knows that the only way to make efficient progress in that scenario is if everybody shares an understanding of where they should go and when. Take, for example, the ability of a sports ball arena to empty 80,000 people in a matter of minutes because they're all heading for the exit, versus the scenario of going to Times Square, where a small fraction of that number of people can cause complete and total chaos. If you have even 10,000 people in Times Square, you will not be able to make forward progress, and that's because nobody in Times Square is trying to go to the same place at the same time. The reason I make this point is because it became very obvious to us that we would need to make concessions due to size. We could not hold the same principles and the same ideals that we did when we were smaller because size changes things. And as I showed you, sometimes you had to make really hard decisions to account for this. And in order to make those decisions, it became very clear that we needed to have clear North Stars. What were they for SBA? Well, we committed to our stakeholders that SBA would make our code more predictable, more easy to debug, and easier to test. There were many, many things that an architecture could do. These are the 3 that we're committing to and that we did commit to. Now, noticeably, you're not saying we're making it easier to write features, we're making it faster to write features, or we're making it more concise to write features. We did not commit to any of those things. You're also not seeing on here anything about clean architecture. These are business-driven North Stars, which is to say, making code predictable makes it easy for us to hire people and get them ramped up into our code base quickly. And making things easy to debug and easy to test takes aim at one of the most costly parts of our engineering org, which is tracking down regressions and fixing them. These are business North Stars. They serve real purposes for our company. Now, they pervaded all the decisions that we made from there. Most especially, one of the primary decisions of SBA, which is that we committed to separating pure changes from stateful changes in our architecture. In order to understand this, let's go back to that little diagram that I had, and let's zoom into the logic layer. Now, our logic layer starts with the basis of a view model. The reason is that we like the lifecycle it provides us. It also does one other thing, which is that it initializes our SBA component and glues together our Dagger dependencies into these SBA classes. It's a very, very small class. That's all it does. The real interest that happens in the logic layer occurs in a class that we call an event handler. Now, the event handler is the only location in SBA that feature state can be changed. The only location. And it also has a requirement that it can only enact pure logic changes. Now, if you're unfamiliar with what this means, it essentially means that for the same input, your function must always output the exact same thing. Specifically, what that means by examples is that it can't do any of the things that makes applications fun. Databasing, networking, reading files like shared prefs, even navigating. You are not guaranteed with the same input to always get the same output, so our event handlers cannot do any of it. Now, what it can do is it can make requests for those things to happen. How does it do it? Well, if we take a look at the interface that defines our event handler and we zoom in on this parameterization right here, we have something called a side effect. And specifically, you cannot see it here, but result carries a list of side effects. So you can make more than one, put them in a list, and pass them back. Now, what happens to these requests to make stateful changes? Well, they go to entities specialized for those purposes, which we call side effect managers. Now, the side effect managers, best practice in SBA is to have them fulfill one purpose. You might have a navigation SEM, you might have a logging SEM, you might have a database SEM. They all are focused on doing their stateful mutation well and doing just one type of them. And of course, they have a similar pattern of communication, a very, very structured communication to the one you've seen between the view layer and the logic layer in slides before this, which is to say that our event handler can emit requests to make stateful mutations to our side effect managers. And in turn, when a side effect manager completes it, it can pass an event back. So for instance, a request might be to load a pin, and an event coming back might be pin loaded or, a failure to load a pin. This is what gets us that commitment to separating our pure logic from our stateful logic. Now, if we look at what that looks like in practice, here's some example code for, say, an onboarding step, where someone inputs an email, and you want to log that, and you want to see if that email's already registered in your system. If so, take them to the login page. If not, take them to the sign-up page. This is how code might look currently. Everything is on the same screen. It's pretty easy to understand in this little snippet. SBA, it doesn't look like this anymore. Now, instead of interweaving these two types of logic, we instead make our pure changes up at the top. We update our display state or some other params that I'll get to later. And if we need any stateful mutations, we have to just create a list of requests to do them. We package it in a result, and then they go off on their merry way. Now, what you're noticing in that last comment is that you're actually not seeing where we handle success or failure, and it's because it's divorced, because it comes back in through a success event or a failure event. And now, if you were me and you were a little bit cynical, you would say, this does not seem like a step in the right direction. What you showed on the previous slide had everything together and it was so easy to understand, and what you're showing here has a layer of redirection where I can't even see the success and failure case. So why in the world would we do this? Well, the reason is because side effects are what make your code unpredictable. If you had no network, if you had no user randomly tapping on the screen, if you had no database that could fail, your app would be 100% predictable, and it would be possible to get a perfect application, because every time your app launched, it would go through the same 10 steps. If there was a bug, it would be 100% reproducible. You could fix it, and your 10 steps would be perfect. The thing that causes errors in your application are side effects. And more importantly, side effects cascade their chaos to everything downstream of them. Now, to see what I mean by that, we can return to this example. Let's just focus on the one side effect of looking up whether an email is registered. In this case, we can see that there's a top-level branch. Either that network request succeeds or it fails. We now have two pieces of code that we need to maintain. Now, you don't see it here, but it could fail in multiple ways. Maybe the user is offline and we want to show a toast. Or maybe the backend is done, in which case we want to say an uh-oh, try again. Or maybe the email wasn't a valid format and we want to update the UI to say, hey, can you please input a valid email? So even in that failure case, now we have another 3 branches. And in the success case, likewise, we can have the email already registered in our system, or maybe it's not there. 2 more branches. This one side effect has now introduced the need to maintain 5 separate code paths in our code base. And how do bugs often get in our code base? We test 1 or 2, we forget the other 3, and our users hit those 3. It adds a lot of maintenance. And of course, this is not even talking about the view layer, where we have things like loading states. Hey, if we don't have side effects, we don't need any of the stuff that goes for loading, because we're never waiting for data, we always have it. So when we return to the 3 North Stars of SBA, and we look at our decision to separate pure versus impure mutations, it is costly, but across the board, it checks off our goals, and it gets us far closer to where we want to be than what we give up. So if we put everything we've discussed so far on one screen, it looks something like this. And we're about ready to start talking about the pros and cons of what we've implemented, but I want to make one more call out, which is that these communication primitives that I've highlighted here, our side effects, our events, and our display states, they're all just data classes or objects that adhere to a sealed interface. And because they're relatively simple implementations, they're not huge, in SBA, we made the decision to put them into a single file called a schema. Every feature in SBA has a schema, and it includes the 4 definitions for these things. What this means is that if you are looking at an SBA feature, you can open its schema file and you can know what its view looks like because you have its display state. You can know all of the events that are possible to affect that feature. You can also know every type of mutation that it can request. And you haven't heard VM state yet. It stands for view model state, but it is a description of what state your feature needs to hold in order to function. So by opening this one file, you have all of these things defined for you. And again, when we look at our North Stars, we see that this checks a lot of boxes for us. So our fuller picture of where we ended up is something like this. Is it still missing details? Yes, because this is not an implementation talk, but this is everything that you need to know at a high level to understand part 3, which is how we feel about the decisions now that we've made them. Now, before I go to part 3, I want to give a caveat, which is that SBA is very much in its Natasha Bedingfield era, which is to say the rest is still unwritten. Now, the reason for that is that frameworks at Pinterest roll out roughly along a 6-step process, which is that you build the thing, you make sure the thing works, you work with early adopters on the thing, then you kind of step back and let people adopt it organically. At some point, you're very confident that the new thing is great and everybody should be using it, so you have a new code mandate, and later still, you realize code fragmentation is bad, let's get rid of the old thing because the new thing is really great. This is usually the step right before you create a new thing and start all over. We'll just leave that off the slides. So where is SBA? Right now, it's in step 3. So what that means is that we've built it, we've validated it, we've made sure the performance is equal, we've shipped our own features and proved that it works on those features, and we've worked with our early adopters who are really passionate about SBA to ship their features. But it also means that there's a lot of knowledge still yet to be learned. That doesn't mean the insights we have now aren't valuable. It does mean that they're incomplete. So take that with you as we go into the next section, which is that we're going to overview some of the decisions that I've just gone over, and I'm going to call out explicitly what I think the pros and cons of each one that we've made are, and some of the things that we still don't have enough information to know. And lastly, I'm going to conclude with 5 things that we learned rolling out a new architecture on the organizational front. Because as much as engineers would like to have it be that you can just write good code and it will speak for itself, that's not actually how it works in the real world. You need both technical excellence and organizational strategy to find success. So let's return to that first decision that I put on screen, which is that we were recommitting to removing all logic from our view. Now, what do I like about this? What do we like about this? You get a single source of truth, which is to say, in our version of MVP, where there was logic in both the view and the logic layer, if you had a bug, you could not be sure where it was going, or where it was coming from, I should say. You would have to go and find where the logic occurred before you could even fix the logic. That's a whole nother step to debugging and fixing bugs. Now, there's also the traditional point that everybody makes, which is that if you have logic in the view layer, it's hard to test. This is indeed true. But of course, the benefits of this single source of truth and better testing are also offset by the fact that you now have simple things that are a bit harder to do. So for instance, I was working with an early feature adopter this week where they had inserted 3 lines into on backpress because they had a full screen modal. And when the user pressed on backpress, they wanted the modal to collapse instead of getting rid of both the full screen modal and the fragment behind it, which is a pretty reasonable thing to request. Now in the MVP implementation, 3 lines get inserted into the on backpress. It's fine, it's easy. In SBA, we had to ask them to send an on backpress event to their event handler to determine whether the whether the full screen fragment should be collapsed or whether we needed to dismiss the fragment because we don't know yet whether the full screen modal is on screen. So we had a little bit of logic to determine that. And then that came back to the view via the display state. So we now had a full round trip. And again, in isolation, this can feel terrible. Although what I have put as the third point on this screen is that even though this started simple, I could almost guarantee that this case of the backpress would have gotten more complex over time. We see this so often that you put a single line of logic in your view, and it's so simple to start, and then someone comes in and iterates on it, and it's not simple 10 months from there. So that is what we like and don't like about that decision. Decision number 2 that you saw me mention. We insisted on type safety, and we continued to pursue sealed events and sealed interfaces. Now, this feels like such a duh moment to many people, but you saw me make mention to the fact that this introduces a huge paper cut to everybody writing SBA features, and especially everybody writing features that are complex and have a lot of reusable components inside of them. They need to wrap and unwrap events constantly. So it's not a clear-cut decision, and we had put on the table the question of whether type safety was worth these paper cuts. Now, we decided it was, and we decided it for pretty predictable reasons, which is that the power of knowing exactly what was coming into your system is so hard to outweigh. There are very few things that can overcome the benefit of knowing exactly what is coming into your system and only having to handle that. Side benefit of that is that you get those compilation errors, and we get them in our source code, which is great. We also get them in our test code, which is also great. A lot of people run test coverage suites to see whether they've hit all of their cases. Because of the way our code is set up, and actually thanks to that engineer who's hiding in the corner over there, thank you, Kurt, our tests will fail if you don't test all of your events. So we don't need to do any post-processing now. We can just say you've tested all your events or you haven't, and it's very, very easy to get that insight. Okay. The third decision that you saw me reference was that decision to separate rigorously pure and impure mutations within our MVI implementation. Now, the benefit of this, as you heard, was that side effects are what destabilize our code. And so when we can push them into a corner and isolate them from all of the rest of the code, all of the rest of the code becomes so much easier to reason about. That code no longer has race conditions, that code no longer has issues being reproduced because it always has the same output for the same input, and it's very easy to trace because you know you don't have any asynchronous work going on where you have to kind of go through multiple branches. Also, it allows our feature logic to be tested very cheaply, i.e. at the unit test level. Now, what are the downsides of that decision? When you separate things, you introduce the need to coordinate between them. When they live together, it's fine. They can just interact with each other. When you move them to two separate places, now you need some mechanism to coordinate between them, and that mechanism is, something extra that your developers have to do that can slow them down. Now, there are two open questions that we have about what we've done here. One, this is a huge mental shift for people coming from MVP. A lot of people in our org don't actually or didn't know the definition of pure code versus impure code. That alone, we have to onboard them to. And then we also have to, in code review, make sure they hold this line because it's very sneaky. You can sneak in stateful mutations if you're not paying attention. You would find them at testing, but still, that's not ideal. The second question that we have is that we're operating against Pareto's principle, which is that we have a hypothesis that we can do 20% of the work and 20% of the testing to get 80% of the benefit. What I mean by that is that we believe that testing our event handlers will get us the vast majority of the benefit compared to a carte blanche testing mandate across all the code in our code base. Now, we could be wrong about that. That's an open question, but it is the hypothesis that we're going with right now. The fourth decision that you heard, or that you heard me reference, was that the event handler is the only thing in our system that can change a feature state. What is the benefit of this? It should be obvious. If anything is going wrong in your system, you know exactly where to start, because there's only one thing in this entire system that can change your feature state, and it's an event handler. So go there to debug, and indeed we have debugging tooling focused specifically on that case. Now, the downsides of this, it can feel very heavy-handed. That's a very prescriptive approach. Two, we have to make compromises because this is actually not how the Android framework works. So we have things that we call one-shot events to basically compromise with the Android framework. And three, by forcing everything to go through one point of time in one event handler, those communication primitives can get quite large. If you have a very complex feature and you force all of that information to flow through a single point, your display state can get quite large. Okay, the last decision was actually less of a decision and more something that hopefully was a theme that you saw on the last slide, which is that each of the three components in our SBA features have very, very strict responsibilities. And as you saw with those communication primitives, extremely scripted communication approaches. Now, the benefit to this is that you know exactly where you need to go to make changes. If you want to change the view, you need to update the display state, and then the view needs to bind the new display state. This also gives us predictable drop-in locations. Do you want an overview of the feature? Go to the schema file. Do you want the implementation details of the feature? They're all in the event handler because it's the only thing that can change feature state. Now, the downsides of this, again, you've heard this theme, it can feel heavy-handed. It's very, very prescriptive. And also, we've taken on a very high onboarding cost. We need everybody to understand exactly what these classes with new names do. And of course, these names are particular to Pinterest, so we can't rely on the entire community's worth of blog posts the way we could with MVP. And also, we need to onboard them to concepts like pure changes versus non-pure changes. It's a very high onboarding cost, and that's nothing to sneeze at. Now, three things that we're keeping an eye on because we don't yet know how they're going to play out. One, the potential to parallelize feature work. Because we have three separate features and they have very clear boundaries, you could work on the view and all you need to do that is a display state, which again is a data class. So you could just construct one, go off and build your view, and you never have to be hindered by the people working on the event handler or the SEMs. Likewise for those other two components. All you need to do is create an event, which is a data class, and you can be off and running with your event handler implementation. conduct because they weren't sure how to get the right level of detail to let people give them real feedback without overwhelming them. And they said, I'm really excited about schemas because I think it's going to strike that balance, and our code reviews can be more meaningful and our architecture decisions can be too, because again, those schemas say what the view looks like, what events it can react to, what mutations it can request, and what state it needs to hold. That's a pretty powerful foursome. Now, the last thing we're keeping an eye on, and the one that I'm most excited about, is the ability for our architecture to operate as a platform. Because everything is very, very scripted and prescriptive, all of the events flow through one location and they're all taking the same format, we can build cross-cutting tooling for them, a lot of cross-cutting tools. And one of the ones we're investigating right now, as an example, is being able to give free performance spans to any feature built on SBA. As a scaling org, things like that are very exciting. All right, now for those last 5 takeaways. Bear with me, everybody. The first thing we learned from an organizational perspective is that better isn't nearly as compelling as exclusively. You can do a lot of things in SBA better than you can do them in MVP, but we do not have that shiny gold thing where if someone says, why should I go to SBA now? We say, here's a thing that you cannot do in SBA. That doesn't mean you can't be successful, but it has made our adoption journey a lot harder. We have had to work to pitch ourselves a lot more than we otherwise would have. 2, we learned the hard way that if you want to get people to adopt your architecture, you need to get on their OKRs or whatever your company uses to track progress. This seems so obvious, but it's actually pretty tricky in practice. You don't know exactly when your architecture will be complete, when you'll have ironed out all the bugs. But if you don't do this, you put the developers you're working with in a source of conflict because they either adopt it and put off their other responsibilities they've committed to, or they don't adopt it even though they're interested and want to. 3, we learned the hard way again that you should be very careful about when you roll things out. For instance, if advertising is a big part of your business, maybe rolling out a new architecture right during the biggest advertising event of the year is not ideal. Likewise, if you work at a tax prep company in the US, maybe try to avoid April. 4, making things easier for people can often make them easier for tools. You heard me reference this in terms of what we're excited about of the architecture potentially acting as a platform, but one of the things that completely smacked us out of left field, and I'm kind of embarrassed to mention it because it's such a buzzword, is AI. Oh, I made it so close to the end. But it turns out that SBA works astonishingly well with Copilot, like really, really, really well. And in hindsight, this makes sense because SBA is incredibly predictable. That was one of our North Stars. So when we integrate Copilot with SBA, it can write entire test suites for us, which is a little bit terrifying, but it can. It can also write a lot of our event handler code, and it's even written big parts of our SEM code for me in the past as well. Last point, and this is one that my colleague Rico brought up. I started this presentation by saying we were operating against a background of change, and it felt like things were coming fast and they were coming often. What was our reaction to that? We added one more piece of change. And I think this change was worthwhile and it was something that we should do, but there is a huge risk of fatiguing your developers. They had already migrated to GraphQL. They had already migrated to coroutines. We have a project to change our lifecycle, and now we're rolling out a new architecture. If you don't let people anchor against their progress while you do this, you can really risk a lot of organizational fatigue. Now, speaking of fatigue, you probably all are feeling a bit fatigued right now and want to get out of here. And coincidentally, I'm out of slides, so you get to. Thank you all for being here today with me. I really appreciate you.